Pheromone trails. Another manifestation of emergence or swarm intelligence beyond the logic of flocking behavior is the logic of the pheromone trail, the way in which ants will follow certain pheromone trails laid by other ants, and so on. This itself leads to all sorts of possibilities within the world of nature itself. A common manifestation of this would be, for example, the logic of the slime mold. The slime mold, which is found in many gardens, is a straightforward phenomenon, but nonetheless it's actually fascinating. And it proved, when it was first discovered and understood, it was certainly, for scientists, it proved to be an astonishing form of behavior. How was it that this particular entity, composed it as it was of many thousands of agents, could both operate individually and then at certain moments come together and operate collectively when foraging for food? An interesting experiment was done using a slime mold to try and track and map the logic of the metro stations, the subway stations in Tokyo. Here you can see these individual pieces of food that are attracting the slime mold, and the slime mold is searching out for these things. And you can see it kind of on the left-hand side, looking at and finding nothing, and therefore withering away. But when it does start finding a sort of dominant trail, it starts consolidating itself. This is, of course, an oversimplification. We cannot overlook the other aspects of what's happening. What about the rivers, the contours of the land, and so on? It is much more complex than that, and certainly a city could be not simply modeled in so straightforward a way. Nonetheless, this particular experiment does point out the way in which the foraging behavior of slime mold does start dictating certain logics of the pheromone trail. One can see this with humans too. This is a photograph I took from the plane once flying back from Beijing. It's, I think, somewhere in Siberia. And looking down on this scene, you can see the difference between, on the top there, the road that has been engineered to be very precise and very rectilinear and to follow a certain top-down logic, and the way that pathways start emerging. Pathways are emerging from where people are kind of following the pathways led by other people, and slowly they consolidate themselves until they become some kind of dominant pathway. Interesting, there was once an example of a new school of biology that was built, and before they laid out the landscape, a professor of biology wanted to go and see where people would actually want to walk. So there had been a landscape plan that had been laid out in a top-down way, but one frosty morning, this particular professor looked out to go and see where people actually wanted to walk, and you could see the trails laid in the frost of where people were actually walking. In other words, you could actually see the kind of the pathways that were desired by actual people rather than posed in a top-down way. As a result of this particular professor abandoned the initial landscaping scheme and the top-down landscaping scheme and adopted a bottom-up one that was based on people's actual behaviors. Within the context of architecture, you can see how this particular logic is being played out. Here is the work of Kukuja, the practice formerly run by Roland Snooks and Rob Stewart Smith, where what you see here looks very much like the neurons of a brain. It is actually a form that is generated using multi-agent system. And when you compare it to the brain, you can understand precisely why it is what it is, because the behavior is precisely the same. They are both multi-agent systems, and hence they manifest similar forms of behavior. Kukuja did a project once for Melbourne, where they were trying to trace out how you could begin to sort of form these dominant pathways as a kind of urban planning exercise. If the same forms of behavior are manifested in any form of multi-agent system, from ants to brains to cities to software, it would seem to suggest that one could use certain softwares, in this case processing, which is a form of multi-agent system software, to go and map out potential urban pathways. And this is precisely what they've done. The challenge here, of course, is that these are not so easy to constrain in any way. They are not necessarily bounded by certain constraints such as other obstacles and so on. They have their own sort of behaviors, but nonetheless, they can begin to suggest certain forms of operation. They can begin to be used as useful sort of tools to help develop some kind of urban plan.